All right, do younger people use Twitter more often than older? Random sample of 316 adult internet users between those ages. 26% use Twitter. So we're going to define the proportion of adults that use Twitter as p hat sub a, and then p hat sub b, we'll call it, are 30 to 49. So p hat sub b is proportion of 30 to 49 that use Twitter. And I should probably specify over here, proportion of adults, 18 to 29. So we defined our parameter, our statistics here, our p hats, and we want to find the standard error. We want to calculate the standard error of the sampling distribution. Notice this is standard error because these are statistics. 26% and 14% describe the proportion of the sample for each one of these, and therefore we have an estimate for standard deviation, aka standard error. So this is the standard error of p hat sub a minus p hat sub b, or the difference between those two. Younger adults minus older adults. And the way that we find that is very similar to standard deviation. We take the p hat sub a, which is 0.26, multiply that by 0.74, or its complement, and we divide by however many there were. So first one had a sample of 316, and we're going to add that to now the information from the second sample, or the older adults, 30 to 49. So we've got 14% is our p hat sub b. We're going to multiply that by 0.86, or the complement of that, the people that don't use Twitter that are 30 to 49, divided by the sample size, 532, and there's your formula. Plug that into the calc, and you get about 0.0289. Next question, what information does this value provide? Basically what this says is if we take many samples of these sizes, so 316 and 532 respectively, the difference in these samples that we find in these samples will be within 2.89% of the true difference.